Hello and welcome to the Programming in C++ series. We're going to go over some more exercise, Chapter 2 exercise labs. Before we get started, go ahead and smash the like button. If you like the video, leave a comment and make sure you're subscribed to the channel if you are not yet subscribed. If you're already subscribed, welcome back. And just a note, if you do subscribe, it makes it easier for you to navigate throughout YouTube and you'll get notified when new videos are posted. But you have to have a YouTube account in order to be able to comment, like, or subscribe to a channel. But the good news is YouTube accounts are free and they take about 1 minute to create. So take a minute or so if you have not created a YouTube account and create one. And we'll go ahead and get started on the first exercise on this video. And this will be Programming in C++, Programming Exercise 2-21. In this one, we're going to be doing some Newton's law states that the force F between two bodies of mass M1 and M2 is given by force equals, that's the quotation or the statement, in which K is the gravitational constant and D is the distance between the bodies. The value of K is approximately 6.67 times 10 to the negative 8 dyn cm squared over g squared. So, our instructions, we're going to write a program that prompts the user to input the masses of the two bodies, the distance between the two bodies, and the program then outputs the force between the bodies. Your program should be able to work with decimals. So that means, anytime you see that, that means you're going to be doubles, all right? Or later on, maybe floats, but not integers. All right, so let's go look at our code. Nothing to do here. I'm going to go ahead and do a little cosmetic. All right, so let's go ahead and declare our variables. They're going to be doubles, so let's go double. And we'll try mass 1, mass 2, distance, and force. Work there. So we'll do console out, and let's go ahead and enter the mass of the first body. So we got that, and semicolon, then span. Mass 1, console out, inline. Alright, we can copy and paste these to save us some typing. If you want to type it for the practice, you're more than welcome. Control V. So this is going to be the mass. First body, the mass of the second body. This is going to be mass 2. Alright. Let's go down again. Let's copy this one more time. This time, enter the distance between the two bodies. And we'll call that distance. And let's go on down again. Let's go force will equal 6.67 over, let's see, what was that number? It's like 8 zeros. 4, 5, 6, 7, 8. That's wrong. We can change it. Mass 1 times mass 2 divided by distance times distance. enough of those already. So space, semicolon, and let's go cancel out. And let's go the force between the two bodies equals force and inline semicolon. Alright, so we got that. I'll let you look at that real quick before I run it. So we got our variables mass 1, mass 2, distance, and force. Then enter the mass of the first body, mass 1, enter the mass of the second body, mass 2, enter the distance between the two bodies, distance, and force equals 6.67 times mass. Alright, force between the two bodies equals force and line. Alright, so it looks like it's ready to run. Let's see what our output looks like. We gotta put something in there, and alright, let's run that. Mass of the first body 120, second body 210, distance 9, 2.758. So let's go ahead and let's calculate it. If it's not right, I don't think that should give it to me, and that might be missing a 0 or one too many zeros. We'll calculate it. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Everything looks like it's on point. Alright, I'll leave you with the code. Calculates line 9 all the way down, and it calculated great. So we got our 100%. Green if you did get 100%, go ahead and submit it. If you didn't, there's another look at the code. Give it there, leave it there for a little bit. And if you need more time, go ahead and pause it, as we will go ahead on to our next video, and we'll do that right after this. Alright, now we're programming in C++ programming exercise 2-22. And we're going to be doing, so 1 metric ton is approximately 2,205 pounds. Write a program that prompts the user to input the amount of rice in pounds a bag can hold. The program outputs the number of bags needed to store 1 metric ton of rice. Okay. And since we've got space, we'll go ahead and make that bigger. Alright, so everything is good. Let's do a constant up here before we get to rolling. And our constant value is going to be integer, and it's going to be pounds and metric tons. Tons, and it's going to be equal to 2205 semicolon. Let's go down and right there. Alright, so first thing we're going to do is get our variables together, and we'll just do 1 amount of rice, and cancel out. It's going to be our enter the amount of rice in pounds in a bag. Right. So we'll do that. of rice are only variable. Got that wrong too. Paste it. As long as they're both the same, it'll work, but it'll confuse you if you kind of don't do it or don't correct it. If you have a long program, you have to refer back to that. So the best thing to do is make sure you camel case it all the time and correctly. Okay, so now let's do count, console out, count. I said count. That's what I typed. Count. So the number of bags needed to fill A, let's leave that open. Metric ton. Of rice is approximately open, continue this sentence. Pounds in metrics. Metric ton. So divide that by amount of rice. And let's end the line. Okay, so you can see the whole code from there. So everything looks good. Enter the amount of rice in pounds in the bag. Amount of rice, inline the number of bags of rice to fill a metric ton of rice is approximately. Got it. All right. So let's go ahead and run that. Enter the amount of rice in pounds in the bag. 30 pounds. That's probably 2.5. The bags need to fill a metric ton of rice is approximately 1,102. So let's see what we got here. Calculate that. Show the code while that's working for you. In case you need more time with it, don't forget constant integer pounds and metric ton. Pounds and metric tons equals 2205 semicolon. And our IO stream is already included for us. So we did get 100% and we got the green check mark, so that's good to go. So let's go on to our next exercise. All right, let's go into programming in C++. Programming exercise 2-23, and we're going to be doing some. Cindy uses the services of a brokerage firm to buy and sell stocks. The firm charges 1.5% service charges on the total amount of each transaction, buy or sell. When Cindy sells stock, she would like to know if she gained or lost on a particular investment. Write a program that would allow Cindy to input the purchase price of each share, the selling price of each share, the number of shares sold, the total amount invested, or the program outputs the total amount invested, the total amount received from selling, the total service charges, amount gained or lost. An example program is shown below. So this is what we're looking at. Enter the buying price share, enter the selling price share, enter the number of shares sold, total amount invested, total amount received, total service charges, amount gained or lost. Since your program handles currency, make sure you use a data type that can store decimals, so we're going to use double. Alright, so let's go in and get our code. Got a lot of room here. Alright, so let's go ahead and start up top here. Let's go ahead and get our constant, our name constant done. So constant, it's going to be an integer. Actually, it's going to be a double. And it's going to, let's call it service charges. Equals 0.015. Alright, let's get this down here. And alright, so let's start declaring our variables. So we'll double stock by price per share. Alright, stock by price per share looks good. Let's double stock sell price per share. Right, another double stock purchase price. Another double stock sell price. Stock service charges by let's do service charges by and service charges sale. One integer. Let's put it up here in space. And we'll call that shares sold. Alright, so let's bring our code and we're going to do some copy and paste. First one done. Let's call this enter the buying price of each share. Put a dollar sign there this time. Price of each share. Then we go to and we call stock. Stock by price. By price per share. This is why it's not coming up. Stock by price per share. And we're going to do inline. We're going to do our copy and pasting. So let's see. So what's we're going to do next? We're going to do this here, and we'll make this enter the selling price per share. And stock sell price per share. Then let's do it again. This one, let's go enter the number of shares sold. And shares sold. So let's do some math. go. Service charges. Service charges by equals service charges by. Okay, clear it up. So stock buy price per share times shares sold times service charges, all caps. There we go. Let's use this again. Control C. And paste that. Change this to sale. And change this to sale. Alright. Next line. Let's go to stock prices, stock purchase price. Equal stock by price per share times shares sold times service charges by. Chargers. Right, so let's copy this one. So let's go stock sale price. Stock buy price per share. Stock sale price per share. Shares sold minus service charges. Service charges. Sale though. Sale. And let's see. So we'll do our outputs. Alright, let's go cancel out. Alright, let's take a quick break for this. We'll be right back. Alright, console out. And we're going to go with total amount invested. Do our outputs. Do that. Dollars this time. $sign. And let's go to stock purchase price in line. Again. That's total amount received. Received. Everything else. And this is going to be stock sale price. And we'll type this one up. Out. And total service charges. Space right here. Priorities. And let's see. Let's go to the next line and finish this one. Service charges by plus service charges sale and inline amount gained or lost. Dollar sign. No space needed this time. But stand up. That. Now, let's go with. So it's going to be stock sale price minus stock purchase price and inline. Right, so I cleared up. Take a look at this again. Starting from the top, we got our name constant, which is a double service charges equal to 0.015. 1.5%. Double. Got our variables, stock buy prices per share, stock sell prices per share, stock purchase price, stock sell price, service charge buy, service charge sell, shares sold. Into the buying price of each share, stock buy price per share. Into the selling price of each share, stock sell price per share. Enter the number of shares sold, shares sold. Okay, that looks good. Let's get no errors there. Total amount invested. Dollar space, total amount received, dollar space, total service charges, dollar space, and amount gained or lost. Alright, so let's go ahead and get this ran. And how many numbers to put in. So she didn't say how many shares she bought. Enter the buying price of shares. So we get to enter that. So buying price of shares, let's go with Tesla, 220. Enter the selling price per shares. Actually, let's go 333. Enter the number of shares sold. So she had 185. So amount gained or lost. What? Total share. That's not gonna look good. Might do wrong here. Alright, let's calculate it. Total amount invested. Get those numbers. No, I didn't. Alright, let's run it. Or let's calculate it. Got one task, so it's not gonna look good. You can convert that number, but I'm not going to do it now. So let's see, my math. Stock share price, share sold, service charges. Boom. So what are we not seeing? Does it tell us? So unable to find enter the buying price of each share, enter the selling price of each share, enter the number of shares sold. Is that what they're asking me to take my wording in that? Yeah, I did. Buying price of each share. Alright, let me look at this close. When I find out what I did, I'll come back. Alright, I did it. I redid it. And this is what we got. We calculated. And I'll show you the code again. I didn't see anything wrong. But I redid it without talking. And I was able to get the actual number from the code. This is what I got when I read it. So she made $11,396.70. Service charge of $663. Bought Tesla at $120. Sold it at $210. She had 134 shares that she sold. So let's see what we got with our calculation here. Alright, so that was it. These long ones are not too long. So we got 100% and we got the green check mark. So I'll show you the code. You can look at that over there. Alright, so from the very top on line 5, that's what we got. So from line 5 to 25, yours looks like that. So if you were still working from 8 to 25, or from line 5 to line 25, go ahead and pause it. I'm about to scroll down. Right. Here we go. 25 to 42, or 44, I should say. And if you're still looking at 25 to 44, go ahead and pause it. Right. It'll scroll down. And that's it right there. Right. If you need more time on that, go ahead and pause that as we're going to go on to the next lab. So our next lab is programming in C++, programming exercise 2-24. A piece of wire is to be bent in the form of a rectangle to put around a picture frame. The length of the picture frame is 1.5 times the width. With a program that prompts the user to input the length of the wire, the program then outputs the length and width of the picture frame. Correct output calculated and displayed. So let's get started. So we got nothing, no name constant this time. So let's do our cosmetics. Alright, so first we'll see our variables will be double. The wire length. And over double, we'll go with width. And then console out. And let's go into the length of the wire. Semicolon. And it's going to be wire length. Colon. And line. And width equals wire length divided by 5.0. So that is a frame. Cancel out. So frame length space and 1.5 times width. This is inline. And last, cancel out. Frame width. Quotes, frame width, and then we'll do width, and inline. All right, let's get this up. All right, let's take a quick look at this again. Got our variables, enter the length of the wire, and wire length, inline, wire length is divided by 5.0, and everything looks good. So let's go ahead and run this. Enter the length of the wire, 26. All right, so let's go ahead and calculate that. Oops. Put it down, and I'll bring you back to the code so you can look at the code in case you didn't get it on the first try. You made a mistake. I'll even go ahead and make it larger for you. So, all right, so there it is from line 8 to 18, the short one. So while we wait for this to calculate, and it's got a green check mark, so we got our 100%. So if you got 100% on this one, go ahead and submit it. If you didn't get 100%, go ahead and look at the code again. I'll leave it there for a few seconds for you to make sure that you got it. So if you need more time, go ahead and pause it as we're going to move on to the next exercise. But we'll do that right after we've returned. All right, we're on programming in C++, program exercise 2-25. And in this one, very similar to the last one, a piece of wire is to be bent in the form of a circle this time to put around a picture frame. Write a program that prompts the user to input the length of the wire. The program then outputs the radius and area of the circle. You may assume that pi is equal to 3.1416. Declare pi as a named constant with the value. So we'll be going up top. So we got two correct output calculated and displayed, and pi declared as a constant. All right, so that's cool. So you can do it without that a longer way, but let's do that first. Let's do constant double, and we'll call it pi equal to 3.1416. All right, let's put this down, get our cosmetics together. And let's get ready to code it. All right, declare our variables. We're going to have same double wire length. I can't spell length good. L-E-N-G-T-H, wire length, comma, I'll just put them on the same time instead. Radius. Right. Now we got cancel out. Enter the length of the wire. Wire. And cancel in wire length. Spell it more. And inline. Radius equals wire constant pi there is. And semicolon there. And we got cancel out radius of the circle. Circle. Radius. In line. And then we got cancel out area of the circle. Copy these if you want. And area. So there. All right. So let's look at our code again. Got our constant. Doubles wire length and radius. Enter the length of the wire length and length. Radius equals wire length times or divided by 2 times pi, and radius of the circle. Radius and area. What do I got? Area of the circle. Oh, that's why I can't do that. Let's do this one. Pi times radius. And there's no variable for there. Let's go pi times radius times radius. And then inline, because there we go, inline. Alright, so now let's look at our. Alright, let's go ahead and run this. I think we got it licked. See? I'll leave you with the code while that calculate or whatever. Enter the length of the wire, the length of the wire, 46, 45. There we go. It looks good. So now I'll calculate it and leave you with the code while it calculates. So if you got something you didn't get it, you can get it. So like I said, the name constant from line 5 all the way down to line 19 was our code. So make sure you got that. And the more you do this, the more you practice, the better you get at it. So don't get discouraged. I still make mistakes, and I'm good at making mistakes. All right, so calculate grade, we got 100%. We got our 2 green check marks, task 1 and task 2. So that's all for that one. I'll leave it there for a few seconds. If you need more time, go ahead and pause that. But we're going to move on to the next exercise. Programming in C++, programming exercise 2-26. And a room has 1 door, 2 windows, and a built-in bookshelf, and it needs to be painted. Suppose that 1 gallon of paint can paint 120 square feet. Write a program that prompts the user to input the length and width in feet of the door, each window, the bookshelf, and the length, width, and height of the room. So the program outputs the amount of paint needed to paint the walls of the room. All right, correct output calculated displayed. And it looks like we're going to be pretty. So we got to do, hold on, look at this again. All right, door, window, 2 windows, bookshelf, and length, width, and height of the room. Yeeks. All right, we got some work to do, but we'll do a lot of copy and paste in here. So let's do our constant, name constant, and 1 gallon of paint. So we'll call that constant double. Call it 1 gallon paint area. And that equals 120.00. So this is a double. And there we go. Alright, so let's go cosmetics. And we're going to go ahead and start with our doubles. copy and paste some second these since I hate typing length. NGTH double width. Alright, we've got door width. Alright, so what we're going to do is copy and paste these. And this is going to be window 1. This is going to be window 1. It's going to be window 2. Probably should have just copied the window 1. Window 2. And window 2. Spelling issues. The next one's gonna be bookshelf. And bookshelf. And again, okay, room length. And room width. Last one. Room height. GHT. And another one. Double paint area. And let's see, anything else? Oh yeah, amount of paint needed. Paint needed. Alright, so I should delete things again. Cancel out. So we wanted to say enter the length and width of the door. THs. The length and width of the door. And let's go semicolon. So that in. Fingers. Door length. Alright, so we got to just copy and paste again. So let's go down to here. And we got here. So enter the length and width of the first window. And then it's going to be window length, window width. Window. that. We'll use this one since we're going to do window again. Copy, paste. Enter width of the second window. And we change this to window 2, window 2. Alright. Now let's go enter length and width of bookshelf. So let's go up, set of the second window of the bookshelf. Word. One word. And we got bookshelf. Gotcha. All right. Gas here. Enter length, width, and height. And height of the room. Room and room width. Height. All right. So room length, room width, room height. Enter the length, width, and height of the room. And now let's do some math. Do our paint area. Paint area is going to be equal to 2 times room length times room height plus 2 times room length, room width. Room width times room height. There we go. Make this a little bit, that'll fit. So we'll just use that minus, we'll come down, tab, minus door length times door width okay, this math is driving me crazy. Minus window 1. Let's go with length times width. Length times window 1 width. Alright, so come back here. Minus window 2 length times window 2 width minus bookshelf length times bookshelf width. semicolon. Okay, so let's go back over here and let's, almost done, but let's take a quick break here. We'll be back after this. All right, let's go. Welcome back. Okay, so amount of paint needed. Paint needed is going to be equal to paint area divided by capital 1 gallon paint area, and that's a semicolon. We're almost done. Cancel out the amount of paint needed to paint the room. And what was the last one that we needed to do? Okay, so no, we'll leave that on there. There's just one line here. Amount of paint needed. And gallons. Period. So there's going to be a word in front of there. There's going to be a sentence. This is going to end the sentence. So we'll leave that there and in line. All right. So we got a lot of type in. We're set. Let's look at this again real quick. 1 gallon paint area. Yes. Paint area. Find these now and correct them. All right, so that one's all right. 1 gallon paint area goes 120.00, and there's our variables 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 variables. Door length and width, window 1, length and width, window 2, length and width. Bookshelf length and width, room length and width, and height, paint area, amount of paint needed, enter the length and width of the door. All right, we're going to run this baby. If we find something wrong with it, we'll come back to it. If not, I'll show you the code that goes good. So let's go with 405. That's not promising at all. All right, so that's not promising at all. I need to paint the walls in the room. Did I subtract that correctly? Let's look. All right, we'll look at it, and I'll be right back with you. Again, show the code. Let's do 45. Turn the length and width of the door. Enter. Still nothing. Calculate. That's not. I know that's not right. It's not doing anything. Look at my variables. See what we get. Or at least this will tell us where to look. And we will go there. Let's see. Thing out of line. Nothing looks like it's out of blank. So it didn't print anything out, but we did get task 1 green and got 100%. So I'll leave you with the code real quick one more time. So you got constant double 1 gallon paint area equals 120. And so let's take you, that's number 5. So 5 to 21 or 22. If you need more time, you can pause it. Going down. All right. So 22 to 37. If you need more time, go ahead and pause it. I'll roll on with this one. And this is a long one. Get this code out here. There we go. All right. One more time for that. There's our top. And on down to next chunk. There you go. And now this one. Right. So let's go on to the next exercise. And we're going to be doing some of the old. Okay, one easy way to do this one. This is programming in C++, programming exercise 2-26. You can go back to 2-25, and copy and paste your code, starting with double door length, the variables, and then we'll just update it from there because instead of typing the whole thing over again. But if you want to type the whole thing over again, you're more than welcome. I'm not going to go that route. I'm going to go ahead and. So let's go ahead. A room has one door, two windows, and a built-in bookshelf, and it needs to be painted. Suppose that 1 gallon of paint can paint 120 square feet. Write a program that prompts you to input in feet the length and width of the door. The length and width, same thing as that one. The only difference is we're not going to use a constant. So what we'll do is let's set it up. No constant this time. This here, so we got room to copy and paste. So I'm going to copy it all the way down from down to the bottom. This is 26, Control V, and this is what 26 or 25 look like. All right. There's 25 look like. So everything but the constant got copied. All right. So now we're at 26 rolling. Time. Go down to inline. I didn't do inline, left it alone. And what? Okay, there. So 1 gallon paint area. So I didn't copy the constant, left it alone. So now we'll just go ahead and correct it as needed. So get the right one here. So we got our variables: door length, door width, window length, window 1 length, window 1 width, window 2 length and width, bookshelf length and width, room length, width, height, and then we got our paint area. Skip the space at that time. Double amount of paint needed. So here, let's see what we need to do for this one. Enter the length and width of the door. Door length or width in. Enter width of the door. So let's go down. All those look like they're good to go. They're the same. Bookshelf width. So only thing we need to change when we do that. Enter the length and width and height of the room. We need to enter the painted area. Let's go ahead and do this. Make room for this one. I'm going to copy and paste this one. And since we don't have the constant name, the name constant, we have to put it in down here. So enter the area that can be painted in 1 gallon of paint. Into the area that can be painted in 1 gallon of paint. In 1 gallon of paint. All right, and So this one would turn to 1 gallon paint area. Oh, I have to add that up here in our variables. 1 gallon on paint. 1 gallon paint area. Alright. So, with that said, we need to add this as a variable. Let's see. Yeah. Yep. 1 gallon paint area. Don't I have that down here? So we take this off, amount of paint needed. Oh, we still need that. Let's do right here. Double 1 gallon paint area. So that's what we're missing. And so when we did that line, 1 gallon of paint area, it cleared up. So now when we do these math, that stays the same. Amount of paint needed equals paint area. Now you just turn this into 1 gallon paint area. That's the variable. Copy and paste it from here. I don't have to type it again. Alright, so it looks like we're good to go. And I'll show you that code if everything runs okay, which it should. To calculate. Let's look at the door. Let's go 55 this time. Alright, let's calculate it. I'm showing you what I did. So, remember, we did not copy the constant. We used the constant as a variable. So these stayed the same. We just added 1 gallon of paint area as a variable instead of having it as a named constant. And we did our code as such. So let's go ahead and go from line 8 to 23. Oh, we got our green, so we're good to go. And we got our 100. So show you the code while we do that. Line 8, the first variable, to line 27. If you need more time for those 8 to 27, go ahead and pause it. And we're moving down. 29 to 47. Leave that there for a second or two. If you need more time for 29 to 47, go ahead and pause it. Go ahead and go. And that's all for that. All right. If you need more time with that, go ahead and pause it as we're going to move on to the next exercise. Programming in C++, programming exercise 2-28. In an elementary school, a mixture of equal amounts of nuts and dried fruit is provided during lunch. Suppose the number of calories in each pound of nuts is 0.70 times the number of calories in each pound of dried fruit. Write a program that prompts the user to input the number of students in an elementary school, the number of calories required for each student from the mixture, the number of calories in each pound of nuts. The program outputs the amount of nuts and dried fruit needed for the students. For simplicity, assume that each student requires the same amount of calories. All right, so we're going to use a constant on this one. Make it easier. Let's get this cosmetics. All right, so let's do that. Let's go constant, make it a double. And let's go fruit, nut, fruit. Should I spell it right this time? Nut, calories, ratio. That's equal to 0.70. Right. So let's get to doing these variables, number of students, integer, and then doubles, or calories per student. Then we have total calories. Calories per pound nut. And then calories per pound dry fruit. Calories per pound mixture. Let's go here. And calories needed, or total mixture needed. Alright, we've got those variables declared, so let's take this quick break and we'll be right back. Let's get our outputs. And we'll do some copying and pasting a little bit. Enter the number of students in a school. Quotes. School. Come on. School. That's going to be number of students, Alright, messed up. Find you. Student. So it's got a student. Calories. And all the rest of it. This is, okay, got it. Alright. Semicolon. As well. Let's go ahead and copy and paste these. I've got a couple more to go. Enter the calories required for each student. Change this to calories per student. Student. Some code's already there. And then let's go ahead and copy and paste one more time. Now we're going to go. Okay, let's get this right. Enter the calories. Enter calories in 1 pound of nuts. Right. So we'll enter the calories per pound nut. Oh man. I got that one. Yeah, I do. Oh, you're not. Okay, got you. Copy from up here again. Calories per pound nut. Copy from up here. Do not have to type that up. Calories, I spelled it wrong. pound dry fruit mix is going to equal calories per pound net divided by fruit net, capital fruit net calories ratio, and then semicolon. Let's go ahead and copy this, paste it. Next is going to be calories per pound mixture. So, dry fruit mixture. Calories per pound net divided by calories per pound fruit. Not stick this out from here. Per pound dry fruit. And then we're going to divide this. Actually, we need our brackets for this one. Divide that by 2.0. And then there's our inline or our semicolon. So that looks good. Alright, calories per pound. Thanks. Now let's go to total calories equals number of students times calories per student. Student, semicolon, and let's go cancel out. Dry fruit mixture and let's go total mixture needed, number 2, and then let's go, we need that pounds, but we need a space, pounds, and period, so we need a sentence, and then inline. Alright, cancel out. Let's mixture total mixture needed divided by 2, and same thing, got the pounds, space, pounds, period, and then inline. Alright, so let's go. I'm going to shorten this one. I'm going to run this one first before we look at the code. Tell me if I messed up. Alright, we're going to go straight to running it. See what we get. Enter the number of students in schools, say 2345. Enter the calories required for each student, 345. Enter the calories in 1 pound of nuts, 20, 40, 247. What did it tell me? Come on. Display, where you at? Dry fruit mixture, yeah, that doesn't look promising, but we'll calculate it anyway. Then we'll look at the code based on the calculations. Something that I'm trying to think. Well, it's still displaying 12. So let's go look at the code. messed out on, and it is going to be failed. Enter the number of students in the school, enter the calories required for each student, enter the calories in 1 pound of nuts, mixed food, error, unable to find a number close enough to 56,539. Program's outputs. So why would I? Alright, let's look at this again. Code must have did something wrong. It's okay. Let me pause it and take a stare at it, and I'll show it to you. So we got 1,200 kids in the school. Calories per student 450. And calorie nuts 325. And now there you go. 684, 163 pounds. Mix, same thing for the fruit mix. Alright, so that looks like it's going to work now. I'll show you the code again. Something was off. But, alright, it's calculating. Let's get this code looked at. So, constant fruit nut calories ratio equals 0.70. And if you're looking at it, let's go down to line 10. I'll let you look at that now. Alright, so we got our 100 for that one, and we got our green check mark. So, with the, if you're looking at this 5 to 20, go ahead and pause it. 5 to 20, going forward. From 22 to the end, that's the end of it. So go ahead and look at that. And if you need any more time, go ahead and pause it, because we're going to move on to the final exercise of chapter 2. So we reached programming in C++, programming exercise 2-29. This is the last one for chapter 2. So let's go ahead and see what we got here. Contractor orders, say, 30 cubic yards of pre-mixed concrete to construct a patio that is to be, say, 4 inches thick. The length of the patio is to be, say, twice the width. Write a program that prompts the user to specify the amount of pre-mixed concrete in cubic yards ordered, the thickness of the patio in inches, the ratio of length and width. Example, if the ratio is 3 to 2, have the program accept a 3, then a 2. Then compute the ratio using these numbers. Program that outputs the length and width of the patio in feet. 1 cubic yard equals 27 cubic feet. To calculate the width, you would need to find the total cubic feet of the concrete, divide the total cubic feet of the concrete by the result of the length to width ratio multiplied by the thickness of the ratio over 12 inches in a foot. So over 12. So square root the answer. To find the square root of the decimal number, include the header file catch using the statement include CMath in your program. The function sqrt included in this header file determines the square root of a decimal number, for example 16.0 equals 4.0. Alright, task 1, include needed header files, correct output calculated display. So alright, so let's get the very easy points is the header file. Let's get this done first. Let's get our cosmetics. And before we go any further, let's go ahead and take a quick break to check this out, and we'll be right back real soon. Alright, so let's get on to it. Let's go ahead and do our include. So underneath our include IOStream, let's do pound include, and let's add our CMath. Alright, then let's do our name constant, and this time it's going to be an integer. Constant int, and let's call it cubic feet in a yard. And we're going to equal 27, as they mentioned. And let's get to writing, declaring these variables. We got double as concrete. And what's the other one? With thickness x, y. And length to width ratio. Alright. So we got 1, 2, 3, 4, 5, 6. Length to width ratio. Thickness with concrete. Alright, so those look good. Now let's go ahead and start our output. We're going to do, first we're going to do, let's see, enter the amount of pre-mixed concrete. And then let's do it in cubic yards. So there. And orders. Okay. The amount of pre-mixed concrete in cubic yards ordered. So let's go semicolon. And then this one is going to be concrete. Comes up. And line. Alright, so let's go ahead and get this copied and pasted. Just a couple more times. So next we're going to do the enter the thickness of the patio, and this time in inches. Inches. Okay, oops. There we go. This is now the thickness. Okay. And we're not going to close that. Yep, that's what we got to go. Okay. Alright, what we not to close that? I'll do it for now. Let's go enter the ratio of length to width if the ratio is 3 to 2. 3 to 2, then enter 3 2. Okay. Enter 3 space 2. And there we go. Yep, perfect. And this will be x y. Do our math right there. The inline is already there for that one. Do that for now. Don't know why, but I know the math. Alright, so let's go do some more calculations. Length to width ratio equals x divided by y. Colon and width equals the concrete times cubic. Cubic feet in a yard. Cubic feet in a yard. There we go. Divided by the length to width ratio. Length to width ratio. Thank you. Divided by thickness, or times thickness. Divided by 12. Is that inches and semicolon. All right. Now what else we got to do? All right, we're almost done here. So let's go ahead and do our cancel out. Oops. And the length width, comma, and thickness of the patio area, or and thickness of the patio are. Here to over tab. Let's say length equals spell that's even worse and worse. GTH, GTH. Sure, that's the spell right. All right, so that's it. All right, length. Back inside length. Length equals. The space there. Space there. And length to width ratio times width, and that will do width, and let's go feet, and our foot, and comma. Going, just go to the next line. And thickness. Something's a foot. Oh yeah, that's right. Still equals space. And you got thickness. And then inches. Inch. Inline. All right, so that cleared. That looks good. All right, give a look at it. Let's go drop it a little smaller so you can see it. The whole thing might be too small, but yeah, it is too small. All right, so let's go. We had our include CMath, did our main constant and cubic feet in a yard. We didn't have a lowercase equals 27. We'll leave it that way. We did our declare our variables, double concrete with thickness XY, length to width ratio. Enter the amount of premixed concrete in cubic yards ordered. Concrete, enter the thickness of the patio in inches. Thickness, enter the ratio of length to width. If the ratio is 3 to 2, then enter 3, 2, like the space after that colon, and then XY. Left this one open. I think that is correct. Okay, length to width ratio equals X divided by Y. And then the width equals square root concrete times cubic feet in a yard divided by length to width ratio times thickness divided by 12, which is going to go from foot to inches. And the length, width, and thickness of the patio area are R. Length of the patio R. Length equals length to width ratio times width, and then feet or foot. Thickness, inch with an S in parentheses. All right, let's run this baby and see what we're doing with it. Let's see what we're gonna do first. I guess I can put whatever input I want. Okay. Enter the amount of premixed concrete in cubic yards. Just go 48. Enter the thickness of the patio in inches, 4. Enter the ratio of the length and width, 3 to 2. Let's go 4 to 3. So the patio, 72 feet, thickness 4 inches. All right. What do we got there? Let's see what we have. Calculate this. And while we do, we'll look at the code again. I'll go over that. Hopefully that's 100. We'll see when it reads up, but we'll start it anyway. So look here. Don't forget your hashtag or pound include CMath. Then your constant integer. We got one missing here. This one is output displayed. Save. Enter the amount of premixed concrete ordered. Enter the thickness assertion. Unable to find a number close to 35,3485. Thickness patio. All right, let's go ahead and look at this real quick and get this resolved. See if this works. Enter the premix cubic yards. Let's go 40. Enter the thickness of patio. So that's 4 inches. 3. So I guess it is 3 to 2. And there we go. Thickness equals 4 inches. And so let's go ahead and calculate it. Up. Still calculating. All right, there we go. We got 100%. We got our test 1, test 2 green. Let's look at the code again. I'll beef it up heavier. Let's go. Bigger so we can see it, and we can see the whole thing. Alright, right, include math. There's our variables, so I'm going to show it to you from 11 all the way down, then I'll make it bigger so you can see it. Alright, so there's line 11 where we declared our variables. Now you can see to 30. I'm going to go ahead and finish this line for you. And that's just a semicolon on line 20. So now you can see the whole thing all the way through, almost all the way through. And so I'm going to go ahead and scroll down. So if you're still working with that area, go ahead and pause. And then there you go. That is the whole thing, minus the variables. Alright, so that's it. Thank you for watching the video and hanging in there. Please hit the like button. Make sure you subscribe if you're not yet subscribed to the channel. And leave a comment. And I'll see you on the next one. That's all for Chapter 2. Take care and have a wonderful day.